Jai Hind. My name is Vikas. I'm an assistant professor in computer science engineering at AKGEC. The topic on which I'm going to present my presentation is data link layer error control are there. The topic that I'm going to discuss the brief of the data link layer, duties of data link layers, types of error that that can occur in the data link layer. Then we have a detection method, and we will be focusing on the CRC, that is cyclic redundancy checks are there. Okay. So, these are the this is in a block diagram in which we have data link layer is resident between the network layer and the physical layer of the OSI layer, where these layers interact with each other. So, are there. There are certain duties that are being performed by the data link layer are packetizations, flow control, media access control, addressing and other controls are there. Data that is being received from the network layer, it is being given to the data link layer, and then the data link layer will give it to the physical layers are there. So, that's a totally we already know that in OSI layer how the flow of controls happens from top layer to the bottom layer, and when we have sending the data from sender to receivers are there. Okay. So, these are the duties are there. The packetization, addressing, error control, flow control, access control. Our in this presentation we are focusing on the error control, but before discussing that, so let us discuss the few points regarding the duties of the data link layer. Means the packetizations, addressing are there. Packetization means the process of dividing the large data size into a smaller one. In this packetizations, we sender at the header which contains the sender and the receiver addresses are there. This packetizations is being done at the network layer, which is given to the data link layer, so that once this encapsulation is being done, now at the receiver end the encapsulations can happen at the data link layer are there. Okay. That is your packetizations are there. And then addressing is we here in this we discuss we can discuss is the MAC addresses are there, how the addresses are being given to the machines are there or any nodes are there. Because in the data link layer, whenever the data is being sent from source to destinations, they prefer the MAC address, or you can say physical address of the systems are there. In this we use the ARP and RARP protocols, address mechanisms, in order to identify the address or the IP addresses are there. Okay. And then we have a flow control. Flow controls is when we have a producer and consumers are there. In that process, once sender is your producer and the receiver is your consumer are there. So, flow control here in this rate at which data is being transferred from source to destinations may differ are there. So, sometimes the receiver end will not receive the data, or you can say they do not have the capability to receive the data at the faster rates are there. So, they have the buffer at their end are there. So, if buffer is full, in that case what they have to do is that for that there are certain mechanisms are there, either they can discard it or they can retransmit the data, ask for the retransmission of data is there after certain time, or we can use the sliding window protocols here, or stop and wait protocols are there. Okay. In the access control, we can we in this we define whether the how the wireless medium in the data link layer, how we are going to access the your rate at which the transfer data is being transferred from source to destination. In this, we use the medium by using the CSMA, CD, Aloha. All these we can discuss in the access control, but this presentation is more focusing on the error control. Error control, there are two types of error are there: single bit error and the burst errors are there. Okay. In this, we have while transferring of the data from source to destinations, the single bit of data, as we know here, during the transmission of data, the data is transferred in the bits format. The single bit is being changed once when the receiver receives the data is there. Okay. Here in this, we here sender wants to send the data with 0 0. This is 4 times, means 6 times 0 1 0 is there, but at receiver end it received it 4 times 0 1 0 1 0 is there. Any, it means we have an error, or we have an anomaly, or we can say there is the data is not in the correct format that we have received it. Okay, that is your single bit error. Another is burst error. In burst error, we have multiple bits are being changed while transferring of the data are there. Okay. So, this is the length of let us suppose we have an 8-bit data is being transferred, 0 0 1 0 0 0 1 0 is being transferred. During the transmission of data over the medium, that this 0 is being converted to 1 1, then we have another 1 and 1 are being converted are there. So, it means we have the means more number of bits are being changed during the transmission of the data is there. That is a burst error of the 8 length is there. So, generally we in the error control, we generally have to discuss how we are going to detect an error and how we are going to remove those errors are there. Okay. So, detection versus correction is there. In the detections, correction of error is more difficult than detection is there. In detection, we only check the error where exactly the error is there. So, either the answer is simply yes or no, means where the error happens. For this, we need to identify at what positions the bits has been changed are there. So, but however, in corrections is more difficult. Because correction, once the check is made, error is detected, it is also need to locate the errors are there. So, detections versus corrections. In the data link layer, we the two things that we need to do is, first thing is we have to detect whether the data is being received is either correct or not. Okay. Once for that, we need to detect any error happens in that or not. For the detections, we have the various mechanisms are there, like your parity check, CRC, your checksums are there. In correction, we have Hamming codes are there, which is being used for the correcting the errors are there. So, generally we for the in the error control, we use the coding mechanism is there. So, redundancy is achieved through the various coding schemes in the error corrections or detections are there. We divide this coding scheme into two categories. One is block coding and conventional coding are there. Here in this, we are focusing on the block coding only. So, when a receiver can detect an error or change in the original code word, if the following two conditions happens. First one is the receiver has a list of valid code words are there, and the original code words are being changed to the invalid ones are there. Okay, so receiver have the valid code words with them. By using those valid codes, they check whether the code that they have received, original code that they have received, is there any deviations from the original codes are there. Okay, so this is the block diagram, how the data is being transferred from sender to receivers, and during the sender to receivers, how the data is being checked, whether the error has been arises or there or not. For this, we use the mechanism is encoder and decoder. Here the message is being transmitted, then we use the generator in order to generate the code words for that message is there. So, once the message is being generated, that is being sent over the unreliable transmission media is there. Okay. So, once the message is being received, now we have to check here. So, in order to check it, the receiver will check with the code words that they have the that is being used by the your senders are there. So, if the message is in correct format, they accept the message and forward it to the upper layer, that is your network layers are there. If the message is not correct, in that case that message will be discarded are there. These are the code words. If 2 bits are the same, then we use the XOR in this. The result is 0. If 2 bits are different, then the result is 1. So, 0 0 by using the XOR, we already know 0 0 is 0, 1 1 is 0. However, 1 0 is 1 and 1 0 is 1 is there. So, this is the methods. If we add to these two code words, or you can say these 2 bits are there, patterns are there given to you. When we add this, we will get the this results are there. This result is an XORing of the 2 patterns are there. So, as we already discussed, I told you that we will focusing on the CRC. There are various detection methods are there. We have vertical redundancy checks are there, longitude redundancy checks are there, cycle redundancy checks are there, and checksums are there. Another is parity checks are there, checksums are there. We will focusing on the cyclic redundancy checks. In this, we generally we are going to discuss how this CRC is being able to detect the error while transferring of the data. Okay. So, in this method, we generally what we do, we use the certain code words to which we have to generate the, by using the encoder, we generate the messages are there. That message is appended to the end of the that message. Once that message is being received by the receiver, now again the same by using the same code words which is being used by the sender, the receiver will check whether the data is being received is correct or not are there. Okay. So, again the same method is being followed. If it is getting the result, all zeros are in there, in that case there is no error are there at the received data is there. So, they can say that we can accept the data, and or if there is any error happens, then we can say we can discard the data is there. So, we will focusing on the CRC here. So, generally this is the methods is being used. So, CRC is an error detection method. It is based on a binary division. In this, we use the CRC generator. Arbing is there. Either we have the algebraic polynomial representation of the patterns, bits patterns are being given to you, or the bit patterns are being already being given to you. Okay. So, if we have a polynomial representations of the data, then we have to convert into the bit pattern into that. Or if there is already bit data is being given to you in the form of bit, then you can generate the code words are for that. Okay. So, CRC is in a algebraic polynomial representation as a bit pattern. Bit pattern is obtained from the CRC using the following rules. The power of each terms given the positions of the bit and the coefficient given to the value of the bits are there. So, this is, let us suppose we consider this CRC generator for the this given polynomial expressions are there, where we have an x7, x6, x4, x to the power 3 plus x plus 1 is there. So, we need to convert this into binary pattern, which we have by using this methods, where we have an x from right to left, we have 1 will be multiplied by the x to the power 0, then again x1, x2, x3, x4, x5, x6, x7s are there. Okay. So, by using that we will generate the binary patterns are there. So, here we generate, this is the 1 is there, when we already know x to the power 0 will get the 1 is there, and x to the power 1 is already being there because x is there. So, we get the result 1 here. As we do not have the x to the power 2 is there, is not given here. So, we will represent this as a 0. So, we will get a 0 here again, and we have an x3, x3 is there. So, 1 into x3 we will get the 1 is there. We have an x4, we will get the 1 again. Then we do not have for the value bit for the x5 is there. So, we will say x to the power 5. So, we will get the result as a 0 is there. Then we have an x6, x power 6 and x power 7s are there. So, we will get this binary pattern for the this given polynomial expressions are there. So, for the given CRC generator, the corresponding binary patterns is being generated. So, this is the binary pattern is being generated here. So, there are certain rules and regulations in order to generate the CRC generators are there. So, for the algebraic polynomial chosen as a CRC generator must have the following adhere, or you can say they must follow the following properties are there. Rule 1 property, or you can say rule 1 or property 1 is there, it should not be divisible by the x. The condition guaranteed that all the burst error of the length equal to the length of the polynomials are being detected are there. Second rule says k it should not be divisible by the x, should be divisible by the x plus 1 as there. So, this will guarantee that all the burst error affecting an odd number of bits are being detected are there. So, in this the CRC generator is chosen according to the above rules are there. How we are going to choose the CRC generator? CRC generator can detect all the single bits error. For that we can detect the double bits error provided the divisor contain all at least 3 logics 1s are there. CRC can detect any odd number of error provided the divisor is a factor of x plus 1 is there. CRC can detect all the burst error length less than the degree of the polynomials are there. CRC can detect most of the large burst error with the higher probabilities are there. So, this is the advantage with respect to the CRC in order to identify the error that is being during the transmission of data. So, for the error detections in the CRC, that is cycle redundancy checks techniques, there are certain steps are being involved. They have to follow those steps in order to encode the message with the data that is being we have to transfer there. Once that encoded message is being added to the intended message, that message being received by the receiver, and now again they use this that same code word in order to detect the errors. So, in order to send the data, or you can say in order to detect the error, there are certain steps are being have to be done by the CRC. The first step is to calculate the calculation of the CRC at the sender end. So, at the sender we have the strings of n numbers of 0 must be appended to the data that we are going to transmit. Okay. So, here the n must be less than 1, the number of bit in the CRC generator is there. So, binary divisor is performed of the resultant string with the CRC generator. We will take an example with the help of that you will better able to understand what we are saying here. Okay. So, after division, remainder so obtained is called the CRC generator. It may be noted that the CRC also consists the n number of bits are there. In the steps 2, we after the appending of the CRC of the data at the sender end, CRC obtained after binary division is there. So, strings of n appended at the data unit early is being replaced by the CRC remainders are there. Okay. So, how many numbers of zeros and numbers of zeros are being appended to the data is being now replaced by the remainder that we have after dividing that data is there. So, at the step 3 we have newly formed code will be generated, where we have an original word, original data, and plus the CRC generators data is being added, or you can say appended at the end of the data. Now, once that has been generated, now that is being transmitted by the receiver, transmitted to the receivers are there. Now, at the receiver end, the transmitted code word is received by the receivers. So, it at the receiver end, the code word, same code words are being used in order to generate the identify whether there is an error in there or not. Same method is being applied here again with the help of same code words. We divide the received data, and on the division of this data we check whether the is there any remainders are there or not. If we receive all zeros, it means there is no error. If we receive any remainder, let us suppose any 1 bits are being there, then we say there is an error is being detected, that message can be discarded. So, generally this CRC happens at the 4 steps are being there. First step, we need to calculate the CRC. CRC generator is being done at the sender end. Once we identify the CRC generator, we append it to the original data. We divided it with the data. Once we have a remainder is there, that remainder is being added or being replaced by the number of zeros from the original initially at the step 2 that we have appended. That now that our original data plus CRC generated data is being transferred over the media. Receiver again checked with the help of the same code words. So, during the transmission of the data, there are 2 possible cases can happen. As I told you, if there is number zeros are being there, then there is no error, we accept the data. If more than remainder is not equal to 0, then there is some error, then we can discard it. So, case 1 says remainder is all zeros are there. If the remainder is 0, receiver assume that no error is being occurred in during the transmission of the data is there. So, receiver will accept the data is there. In the case 2, if remainder is not equal to 0, then what they have to do? So, if the remainder is non-zero, receiver will assume it that error has been occurred during the transmission of the data are there. Okay. So, here the receiver will detect an error. Now, the receiver will reject the data and ask the sender to retransmit the data here. Okay. So, in the CRC, first thing is we have to, with the help of the code word, we divide the data that is being transferred, and we have to add the numbers of zeros at the end of the data, divide it, remainder, whatever the remainder is being received, you get, add it, replace by the number of zeros by that, send it to the receiver, to other node, receiver will again check it. If receiver find the remainder is 0, then it will accept the data. If remainder finds the remainder is not equal to 0, then it will reject it and ask for the retransmission of data. Okay. So, this is an example. We have a bit stream is being transmitted. This 1 1 0 1 0. This is 1 1 0 1 0 1 1 0 1 1 is there, that is being transmitted using the standard CRC method. Here in this we use the generator polynomial, that is x4 and x plus 1 is there. Okay. So, what is the actual bits of string is being transmitted as well. So, we have an generator is there, we have an again x4 plus x3, x2 plus x plus 1 and x to the power 0. This we need to use. So, here this is 1, again this x is there, we will use the 1 here. Here x to the power 2, we do not have any number, we append the 0 here. We place again for the x3, there is no values there. So, we use 0 here. For the x4 is there, so we use the 1 is there. So, what will the output that we will get? That is 1 0 0 1 1 is there. So, this is the clearly the generator polynomial consists of the 5 bits are there. So, now this is the 5 bits. By using this generator, we will divide this number, and in order to divide it, we have to append the numbers of zeros. So, that zeros will be how many zeros that we need to append. For that, we have to, as method says, as the polynomial consists of 5 bits, we can append the 4 numbers of zeros at the bit streams are there. So, we have add the 4 numbers of 0 here. So, by using this generator, we divide this, we will get this remainders are there. How they are being done? As we already know, 1 plus 1, we will get the 0, 0 plus 0, we will get the 0, 1 plus 0, we get the 1, 0 plus 1, we will get the 1 is there. So, by using that mechanism, we will get this remainder there. So, the resulting bit stream will be the this is being used for divided by this is there. So, output, this 4 bits are now being replaced by this 4 number of zeros, and that will be transmitted as well. So, CRC will get the 110s are there. The code word to transmit it is obtained by replacing the last 4 digits of the 0 with the CRC. So, the code word that is being transmitted will be this one is there. Now, at the receiver end, we divide the transmit code word with the that generator code word is there, and we have to find if there is the remainder is 0 is there. If there is an error, then we will not receive the all number of zeros. If there is no error, we receive the zeros, then the data is error free is there. So, this is the at the receiver end, they use this method. Again, we perform the same functions, we get the numbers of zeros again here. So, we will say yes, this data that is being transmitted from sender to receiver or the transmission media does not contain any error. So, we received we haven't received any error in this. Okay. So, this is an example. By using this we can identify the CRCs. So, thank you.